Good evening, ladies and gentlemen. Welcome to another online lesson in statistics. Last time we were looking at linear regression and we did a few examples on how to calculate the lines of regressions for x on y and y on x. So basically, this is the question that was on the activity, and it was asking us to find the lines of regression for x on y and y on x given the data here. So what you were supposed to do for this data, first of all, you need to complete the data first of all. So what you do to complete the data, so after you extend the table like that, you need to create columns for x times y, another column for x squared, and another column for y squared. So for x times y, you multiply the variables, so x and y. So x times y, that would be 9. 4 times 9, that would be 36. 5 times 7, that would be 35. 6 times 6, that would be 36. 2 times 5, that would be 10. Then we come to x squared. So we square each of the terms of x. So that would be 3 squared, that would be 9. Squared, that would be 16. 5 squared, that would be 25. 6 squared, that would be 36. 2 squared, that would be 4. We come to y squared. 3 squared, that would be 9. 9 squared, that would be 81. 7 squared, that would be 49. 6 squared, that would be 36. And 5 squared, that would be 25. Then for each of these, we need to find the sum of x, meaning that we need to add all of x. When we add all of x, we're going to get 20. So that is 3 plus 4 plus 5 plus 6 plus 2. That will be 20. Then we also need to find the sum of y, which will be equals to 30, adding everything, 3 plus 9 plus 7 plus 6 plus 5. Then the sum of x times y will be equal to, so completing summation of x squared will be 90, summation of xy will be 200. I mean, x squared will be 200. xy will be 126. So when you're done completing the table like this, then now you can find the lines of regressions for x on y and y on x. So we'll start for y on x. Y on x, we know that the equation is y is equals to a plus bx. So we need to find b, which is equals to n summation of xy minus summation of x summation of y all over n, n summation of x squared minus summation of x, then everything squared. Okay, then putting in the values, n will be the number of variables that we're looking at. So that is 1, 2, 3, 4, 5. So n is 5. 5 times summation of xy, summation of xy is 126, minus summation of x, which is 20, times summation of y, which is 30. Then divide by 5 times summation of x squared, which is 90. 90 minus summation of x, which is 20 squared. So 20 squared. So simplifying everything there, we get our b as, so we see that our b will be 0.6. So let me just erase everything. So this formula, you should remember it from the previous lesson. So that will be our b, which is 0.6. Now on to finding a for y on x. So a for y on x is equals to summation of xy minus b summation of x squared over summation of x. So we just put in the values there again. So our a will be equal to, so a will be equal to summation of xy, which is 126, 126 minus b, which is 0.6, times summation of x squared, which is 90, divide by summation of x, which is 20. So simplifying everything, our a will be equal to, so we see that our a is 3.6, so we just put it there. So a is equals to 3.6, and we can erase everything down here. Then having that done, meaning that our equation finally is y is equals to a, which is 3.6, plus b, which is 0.6, then x. So that will be our first equation for y on x. And now we go on to finding the regression equation for x on y. So for x on y, we know that the equation is x is equals to a plus by. Okay, so now we need to find a and b. So for b, it's the summation of x, y. So we have an n there, minus summation of x, summation of y, divide by n, summation of y squared, minus summation of y, then everything squared. So again, just replacing there. So our n is 5, summation of xy, which is 126, minus summation of x, which is 20 times 30, then everything all over n, which is 5, summation of y squared, which is 200, minus summation of y, then everything squared, so that will be 30 squared. Okay, so now simplifying everything, we see that our b will be equal to, so we see that our b will be 0.3, so we can just put it there. So b is equals to 0.3. We go on to finding a, so we can rub this, we can erase that. So now x for a for x on y, a is equal to, so for a is equals to summation of xy minus b, summation of y squared over summation of y. So again, we just replace variables there. So summation of x, y is 126, 126 minus b, which is 0.3, times summation of y squared, which is 200. Then everything divided by summation of y, which is 30. Simplifying that, we are going to get, so we get our a as 2.2. So now we just write it there. So a is equals to 2.2. So we can erase everything here. Then our equation will be x will be equal to a, which is 2.2, plus b, which is 0.3 times y. So those are the two equations. Now, from here, we need to find the lines of regression for this, or we need to draw the lines of regression. So what we're going to do is, before we draw the lines of regression, we need to come up with coordinates of points. So for this one, the coordinates, we have x and y. So for y on x, y depends on x. So if y depends on x, then x is constant. So we pick the values of x, which is 3. We pick any two values of x that are a distance apart. So I've picked 3 and 6. You can pick any two that are a distance apart in magnitude. So me, I've picked 3 and 6. So I'll just say 3 and 6 here. So we say 3 and 6 there. Then we'll find the values of y for which x is 3 and for which y is 6. Okay. So after we've created a table of values for for y on x. So we said y on x, y depends on x. So if y depends on x, so we should write the values of x. Then we see what values of y we're going to get with these values of x. So when x is equals to 3, we replace in the equation. So this is the equation, y is equals to 3.6 plus 0.6. Then on x, we put 3. So when we simplify, what are we going to have? So we see that y will be 5.4. So that is y will be 5.4. 5.4. Then when we do the same thing for x is equals to 6, so we put 6 here. When we simplify this, we see that y will be equals to 7.2. So now our coordinates for this line will be 3, 5.7, 3, 5.4, sorry, and 6, 7.2. So these will be the coordinates for this. Then we do the same for x on y. Again, we create a table of values, x and y. So x depends on y. So if x depends on y, then we should write the values of y. Then we see what values of x we're going to get. So values of y, we have 3. Which two values of y can we get that are a distance apart? So we can get maybe 3 and 7. So 3 and 7, they're a distance apart in magnitudes. So we get 3 and 7. So we say y is 3 and 7. Okay. When y is 3, what value of x are we going to get? So we put in the equation x is equals to 2.2 plus 0.3. Then y is 3. We simplify that. We see that we'll get 3.1. Then if we do the same for 7, so when we have 7 there, when we have 7, there will be 2.2 plus 0.3 times 7, that will be 4.3. 4.3. So the coordinates for this line of regression, let me just this. So for this line of regression will be 3.1, 3 and 4.3, 7. So now we're going to go on a graph paper, but before we go on a graph paper, let me just show you that these two will really meet on x bar and on y bar. So first of all, we need to find x bar. So x bar will be equals to the sum of x over n, of which the sum of x is 20 over n, which is 5. So sum of x from the table, that is 20. And when we simplify this, we're going to have 4. Okay, that is x bar. Then y bar is equals to the sum of y over n. Again, sum of y, that is 30 divided by 5, which will be equals to 6. So we see that these should meet at 4,6. Okay, the two lines should meet at 4,6. Now let me just show you that these lines really meet on 4,6 using the graphs calculator. So right here you see, if we put the equation y is equals to 3.6 plus 0.6x, and the line x is equals to 2.2 plus 0.3y, when we plot them, we see that on the y-axis, that is 6, and on the x, that is about 4 there. So let me just zoom in. So we see right there that when we zoom in, these lines are meeting at approximately 6, 4,6. You see, that is 4.00,6.00. So they're meeting at 4,6. And now we have to show this using the our own graph paper. So that is a graphing calculator which helped us do that. So by using graph paper, what we're going to do is we're going to get the two coordinates that we've calculated for this one. These two coordinates, we will draw a line, and these two coordinates, we'll draw a line. Then we'll try to see where they meet. All right, so we are here on our graph paper. So we see that we have the two equations and their coordinates. So what we'll do is we'll make a scale. So we'll make our own scale. So let's do this. So on the x-axis and on the y-axis, just there, and on the y-axis, then maybe we'll let one unit represent. So this is 0.5 to represent 1 unit. So that will be somewhere there. 1, 2, 3, 4, 5. Not there. 5. 1, 2, 3, 4, 5. 1. That'll be 1, 2. Now let me just do this. Let's say that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, same applies here. 0.5. Let me just move this a bit down. All right, so we have our scale there. Then we can just look for these points. So for the red parts, we're looking for 3,5.4. So 3,5 will be somewhere there. 3,5.4, which will just be somewhere there, approximately somewhere there. Then we have 6,7.2. Okay, let me just move these away from here. 6,7.2 will be somewhere there. Then when we draw the line, so the line will be something like that. Right. So that would be the line. Okay, so that would be the line. Then for the other one, we look for 3.1, 3. So 3.1 will be somewhere there, 3, which would be somewhere there. So 3.1, 3 will be somewhere there. Okay. Then 4.3, 7. So 4.3, 7. So 4.3 somewhere, 7. This is where 7 is. So 4.3, 7 will somewhere be there. 4.3, 7. Somewhere there approximately. Then we can draw the line. So from this point all the way there. Okay. Then we see that where they are meeting. So it's approximately not exactly though. It's approximately 6. So we see that we've tried. So that is where the two lines are meeting. So that is 6. Then down there it's almost 4 as well. Just zoom out so that you see. So we see that it is almost 4,6. So meaning that we have tried to approximate where they are meeting, which is okay. So that is how you show graphically that the two lines of regression meet at their means. So this is approximately, this is 3.9 somewhere there. That will be 3.9, comma, that is 5.9 as well. 5.9, so which is almost 4,6. So then that is the end. We have shown that the two lines of regression for y on x and x on y meet at their mean. So this is for that, and that is for that. Now there's a task that you're going to do. All right, so you go. So using the same procedure that we did. So for the following data, find the lines of regression for x on y and y on x. So this is the data. Then show that the lines of regressions for x on y and y on x meet at x bar, comma, y bar. So you're just going to follow the same procedure and work out the problems. So, but for today, this is about it. If you have any questions, please ask. And don't forget to subscribe if you've never subscribed. Thank you very much.